I think I will be making sure. Okay, the meeting is being recorded. I have to be making sure before within 24 hours the meeting is available for you and the rest of the team. Okay, good. So now we're going to look at what we're calling transactions. Okay, we will define what a transaction is. Of course, those are transactions. So the don't worry about what a transaction is. We'll look at that in a minute. Okay, Fanny, welcome. Is the screen okay? Is the screen visible and my audio clear as well? Okay, good. I was worried. I was like, our pioneer, she isn't in the meeting. What's happening? Okay, so we'll look at transactions today. Of course, we will define what a transaction is, but the overview is let's give an example of the University of Zambia Student Information System database. The university. Okay, let me let someone in. Okay, welcome. Could you please confirm, is my screen visible and the audio clear as well? Should be Gertrude. Is my screen visible and my audio clear as well?
Yes, it is.
Okay, all right. Thank you. Thank you. So we're gonna look at the transactions. We will define what a transaction is. But the overview that we are giving about the transaction is about accessing. Okay. There are two terms that most times we do confuse. Number one is authentication. Number two is authorization. Authentication, authorization. Okay. Authentication, it is about though these terms have been used wrongly, interchangeably, so to speak, and quite wrongly, they have different meaning. So authentication is about identity. So if they say you're moving from East Park to the University of Zambia campus, for then you find those gate men and women. When they say for you to go inside the University of Zambia premises, you need some form of identification. That is authentication. So moving through from Kalingalinga through the campus, that is authentication. Being allowed to pass by some form of identification. Even on your phones, you have fingerprints, you have face recognition, and so on and so forth. That is authentication. Please pay particular attention to that. Authorization, on the other hand, is about what you have the right to access. Even when you can enter the University of Zambia, campus, it is about, are you able to access the Vice Chancellor's office? Are you able to access the library? Are you able to access uh, possibly um, uh, possibly a certain room? Do you have the right to have an access to that? That is authorization. So authentication is about the identity. Authorization, on the other hand, is about what you have an access to. That is very, very important. Now, why are we talking about these two? I believe some of us, on if not uh, um, if not all of us here, have um, uh, uh, have been authenticated to the University of Zambia Student Information System database. So you have some form of username, the password, then you get to the Student Information System portal. That is authentication. Then what are you allowed to use in that or on that dashboard? That is authorization. Okay, so now let us narrow down to what we want to talk about. So you are authenticated. Please get used to those terms: authentication, identification. So you are identified. You get to CIS, you are identified, then you get to the dashboard. You are authenticated. So you are authenticated, someone is going to be authenticated, another person is going to be authenticated, another person is going to be authenticated. Okay? So you are going to be identified. Another person will be identified. At the same time, especially during the time of printing the results, um, registering, getting an ID, and so on and so forth, during that time, a lot of students are authenticated to that database. I'm using these terms very, very carefully. Okay? Are being identified. So they enter a user ID, a username, the password, and so on and so forth. So they are authenticated at the same time. Now, look at this. The same system has a lot of students that can be authenticated at the same time without the system to have crashed. Look at what happens. Let's give an example of people who traveled from far, far places. They are taught, come to campus with some form of identification as a proof of you to have had traveled from far, far place. So what are you going to use? In that case, the bus ticket. So that to identify that you came from, for example, Eastern Province, Chipata, Lundazi, or wherever. Now, there are a lot of students that would come from Eastern Province, some of them Northern Province, and so on and so forth. Now, all those people, once they are identified, now they can have an access to a bus. If there is a bus, they can put them in that bus. Now imagine what happens. The bus is, for example, 156 seats, and there are 300 students with their luggages. you load them in there plus the luggage. What is going to happen to that bus when it starts moving? 156 seats, then you load 200 people, for example, plus the luggage. What is going to happen to that bus? Hello? What do you think would happen to that bus? No one is able to answer that? Okay, good. Madam Kasago, what do you think would happen to that bus? 150 seats, they load 200 people, plus the luggage. When it starts moving on the road, what would likely happen to that bus along the way?
It might have a breakdown
It
since
might,
it's overloaded.
okay, it might have a breakdown. That's one possibility. Another possibility? Perfius? Another possibility? I hope I'm not scaring people by asking questions, because we want to establish the background of this transaction. Another possibility? Right. Gertrude, another possibility? Oh, good. Please go ahead. Please go ahead, Perfius. They, they may, okay, they may be charged for overloading. Good. Another possibility, Gertrude? Okay, anything can happen. Tire burst, breakdown. Another possibility, Fanny. Another possibility, accident. That is the perfect response I was looking for. All right. So, um, uh, uh, why would they be charged? Uh, your answers are very, very correct. They will be charged because of overloading, and of course, for you to be charged because of overloading is to put a penalty, so that they make you realize that overloading is the most common cause of road accidents. Breakdown. So when there's a breakdown, a tire burst or anything, because it is overloaded, very, very easy that leading to the road accident. So in database, that's what we are calling crashing. Okay, so you'd find that the University of Zambia, just a Great East Road campus, is a campus of over 30,000 students. The first year, the second year, the third year, the fourth year, the fifth year, the sixth year, the seventh year. Because we do have the doctors specialize in animals, that is an animal medicine. So over 30,000 students, and you'd find that over thousands of these students are accessing the database at the same time. So what will happen to this database? Just like a bus, this database is likely to crash. Okay? That is where the transaction matters. Okay? So we are talking about how do we support multiple people using database at the same time. So how is it possible? How do we make it possible to see to it that Nkasako here is accessing the database, Fan here is accessing database, myself accessing database at the same time without bumping into each other or without the system crashing. That's what we are going to be looking at. Okay, so how do we make sure that multiple people uh, um, uh, use the same database at the same time? One of ways is multiple applications. Okay, is to design this database in such a way that a lot of applications are able to be used. So instead of using just Google Chrome, we can also use Safari, um, Google Chrome, uh, and lots of uh, uh, these applications. That's one way. Also, multiple programmers, multiple analysts, and so on and so forth. So imagine a world where each person has to wait in line to use your database. Imagine what would happen if Perfius is using the database. It doesn't, it locks everyone else. If database was a bathroom, just think about that. So, uh, if I enter the bathroom, no one else is allowed to enter there, not until I finish. Imagine a world where each person has to wait in line to use your database. So if this person, for example, they go to shower, to bath, whichever, then they collapse within that shower, within that bathroom. Everyone else who wants to bath, they wouldn't know what happens there. They will keep on waiting. That is indefinitely. Okay? That those are some of the concepts that we are going to be looking at. So the database that we just use at a moment, like MySQL, is designed in such a way that when one is accessing that database, no one else can access it. That's why we have database like MongoDB, PostgreSQL, and by far the best database is PostgreSQL. And I'm sure, I think one of you guys said, the sir said that's the type of database that we are going to be using. Okay, so the outline is what we are going to be looking at. A database application, common concurrence issues. We will look at this very well. Transaction in SQL. This is the point at which we will define what a transaction is. Okay. Schedules and serializability, conflict and conflict serializability, verifying conflict serializability. These are the concepts that we are going to be looking at. For now, don't panic. Just relax and enjoy. Okay, so before we dive into what we have to do, kindly give me a thumbs up. Are we good there? Okay, good. So here is a single client. Again, a client is not you. A client is a device that you are using. This is not law, where a client, there is this question somebody asked me, what do you think is the difference between a client and a buyer? Very simple question. A client receives a service while a buyer receives a product. So a client is a device that you are using, which is making through which you are making a request. So if you have a phone, then you are searching for a certain concept over the internet. You are making that search via that phone. In that instance, that phone is a client. Okay? That device which is giving or from which a feedback is coming is what we are calling a server. So when you have a single client, so a single client means the application and the data are on the same machine. So imagine you just have a single client. This will be very, very easy. You are the only person there. So you don't expect another client to bump into each other. You are all just the only person there. Okay, so this is used like SQLite, which we used for our assignment. Postgre, I think this is WH13. These are just type of databases. Okay. There is also H2 is also a type of database. So if there's a client accessing a database, there can never be a crash there. So this client accesses SQLite or Postgre or H13 and so on and so forth. So a server is also a device which gives a feedback. That is the simplest explanation that we can give there. Okay, so that server has running resources. It has the resources which runs there, and that's what we look for. For example, database management system that is shared amongst multiple, sometimes concurrent users. Don't worry about what concurrent is. We will look at that. Okay, so this is a good way to look at it. Okay, so this is a client. So this client sends a request. Okay, this is also a client sends a request, and this is a server. Okay, so it's just a machine which gives a feedback to these clients. So now look at what happens here. We have a client here. If this is the only client accessing these resources here, imagine this is where the database is. Since this client is only one, we don't expect the conflict to occur there. But if we have another client accessing the resource at the same time as this client, at certain point you would expect a conflict to occur there. These two transactions can bump into each other. So how do we solve that puzzle? That is what we are going to be looking at. Okay. Don't worry about what a cloud host host is. So the other options that you have, when we say two tier, okay, a tier is just a level, so it's a two-level architecture. What we mean is this: so there is this device which is different from this device. So we have one, two. So this is two-level architecture. If we put another device here, this will be three-level architecture, and this is what we are looking at. So there are other architectures, for example, three-tier, and so on and so forth. So there are a lot of ways of interacting with database, which includes ad hoc. I think we've heard of this term lots of times. Ad hoc is peer-to-peer. It's a situation where two clients talk to each other directly um, in an event of Bluetooth. Okay, a phone and a phone connect to each other directly. That is ad hoc. That is ad hoc there. Okay. There is also a pre-configured query. For example, what happens when you make that phone call through Airtel, MTN? If someone's phone is off, there are all these recording in the system. Okay. If someone's phone is off, or if it rings, because there is time set there, they will tell you there is no response from the requested number. Okay, that is pre-configured query. Okay, there is also special purpose apps. Okay, and so on and so forth. So database applications, this is an application written in general purpose programming language that include calls to DBMS. Database is just an application. Okay, and that has been written using Java, using Python, and other languages. Okay, so this is where our serious business starts. Kindly give me a thumbs up. Are we good up to this point, so that we dive into what we have to we have to dive into? And just a minute. So let us give a minute to one another. Kindly, like our culture, get somewhere to write, because certain concepts that we may need to explain, those may be helpful. So get where to write, get what to use to write, and give me a thumbs up once you get that. I'm muting for now. Have we gotten where to write? Kindly give me a thumbs up. Okay, thank you for that, for those thumbs ups. So, common concurrent issues. Let us go back to this diagram before we understand what that is. So, remember, we've talked about the concept of, just in our very introduction, saying, imagine a world where each person has to wait in line to use your database. Can you imagine that? That's why we put that head there. I really, I'm really, I really am not good at emojis. So please forgive me. I don't even know what that is. I just drew it there. I don't know what it means. So imagine um, this one accesses the database, and this one wants to access the database. So concurrent, we are saying one after another. So if this one accesses the database, this one has to wait. Now, if this accesses the database indefinitely, look at this as a bathroom. So this one goes to bath, lock the door, and faints in there. And this has a program, has to wait for this one that is accessing this database, or a bathroom. Look at it as a bathroom now. It has a program, so he has to wait until this person move out of there. Now, if this person has fainted, this guy here has to wait indefinitely. Okay, so how do we resolve those issues? That is what we are calling common concurrent issues. Okay, so so anyway, I put watch a video called Everything Everywhere All at Once. It's a very nice movie. It's a very nice movie. Those of you like movies can enjoy this movie. Everything, everywhere, all at once. It's just about 2 hours 20 minutes. Those of you that enjoy movies, I hope we do have people here who enjoy movies. Fanny, do you enjoy movies? Okay, good. That is one of the movies to look at. Maybe you've watched it before? Okay. Gertrude, do you enjoy movies? Have you watched it before? Okay. Kasako, do you enjoy movies? Have you watched this one before? Okay. Perfius, do you enjoy movies? Okay, good. Have you watched this movie before? Have you watched this movie before? Please go ahead. Please go ahead. Have you watched this movie before? Sorry for muting you. Yeah, so try watching it. Everything, everywhere, think I have to rewatch it. It's been a while. Or at once. Uh, if I put details to it, I will spoil the booth. So please just be curious enough to look at it. Okay, so common concurrence issues. So when this client wants to access this database, there are only two possibilities of what this client wants to do. Number one is to check for the data. Number two is to make changes. Okay? And please write this down. Write this down. Checking is equals to reading. Checking is equal to reading. Write that down because we will change these terms in a minute. Then making changes. Making changes is equals to writing. Making changes is equal to writing. So we've heard these terms lots of times where we say read, write, read, write, read, write. So when we're just saying read, it means you're just checking. Write is making changes. So there are only two possibilities of this client for which this client needs to access this database. Number one is checking. Number two is writing. This again wants to access the database. He can either check or make changes. That is read or write. So the common issues that can arise, concurrence means if this one accesses the database, this one has to wait. That is concurrence, one after the other. You have three. You have um, three functions that you want to perform, or three tasks that you want to perform. Task A, task B, task C. So task A, if task A starts, it has to finish. Task B has to only to start if task A finishes. Task C has only to start when task B finishes. That is concurrence, one after the other. We will look at these terms at a later stage when we talk about synchronization, non-synchronization. We'll just keep on improving on that. Okay, so those that is concurrency. So from that concurrency can arise issues. From that concurrence can arise issues. So the problems, common concurrence problems, number one, there are just four here: lost update, dirty or inconsistent read, unreadable read, phantom read. We'll dive deep into that. Lost update, dirty read or inconsistent read, unrepeatable read, very important, unrepeatable read, phantom, this is M, phantom read. Now let us dive into each of these. So watch this video. Everything, everywhere, all at once. Dirty read or inconsistent. Okay, so a dirty read happens when data is read during a write. It is also called write, read, conflict. Let's look at this diagram so that you understand there. So it is about this client. This client accesses the database, and this client is not reading, he is writing. Remember, writing is making changes. So as this client is writing to that database, then this client is reading during the course of writing. Okay? This client is writing, and this is reading during the time this client is writing or making changes. Of course, during writing, you can make mistakes. Okay? You want to write small letter T, you write capital letter T, you erase that, then you correct as capital letter T. You wanted to write L, you write I, because L and I have some common presentation. So you write L instead of I. So the data there, which this client is writing, is very, very inconsistent. So as he is writing, this one is reading. That is inconsistent read. So that data which this client is reading, because this one is writing, is dirty. It hasn't been cleaned up. That is what we are calling dirty dirty read, though we started with number 2. So that is what we are calling dirty read. So dirty read or inconsistent read happens when data is read or checked during writing. So there must be a writer first, then a reader. Writing and reading is happening at the same time. So there is that conflict. So there is that conflict. So it is called the write-read conflict. Are we good here? Kindly give me a thumbs up. Otherwise, ask a question. Okay, good. So here, again, let me take this opportunity to ask, those of you that attend classes, have you reached transactions or you've passed? No one attended today's lecture? I'm aware you had a lecture. Fanny, Gertrude, Gasako, Perfias? Have you passed transactions? Or you guys don't attend lectures? You haven't passed. Okay. But you've looked at what we have looked at in the past, not so? Perfias? Okay, good. Thank you. That gives us at a good spot. So look at what is happening. So there's a manager here who wants to balance project budget. When you want to balance, it means you want to write, you want to make changes. That's the only way you can balance. Then there's also a CEO who wants to check campaign balance. This one wants to just check. So this one is reading. Then this one is writing. So this manager wants to balance project budget. So what happens? First, this is a write, then this is a read. So what is happening here is this. So at first, here there is the manager minus here means withdraw. The manager withdraw 10 million from project A. Okay, don't worry about these arrows, we'll explain them. So the manager withdraws 10 million from project A. Okay, then here um, he deposits this plus, he deposits 10 million to project B. Okay, then again he deposits 10 million to 3 million to project C. Now look at this. This is a read. So this one selects the sum of money. So data is temporarily inconsistent at this point. So I want now to focus you on these lines. The manager can't withdraw 10 million without this 10 million being in an account. It means before minus, which is withdraw, this 10 million was there. So here, this is marking. So at the start, before withdrawing, when the CEO checks, because this is reading, so when the CEO checks the money before withdrawing, the money will be 10 million. Okay, but when the manager, when the CEO checks account again, the account has nothing because the 10 million has been withdrawn. Again, the CEO checks, he finds that there is 7 million. Again, he checks, he finds that there is another 3 million. So at this point, all these figures are very inconsistent. So you withdraw 10 million, remains 0, but time there is 7 million, time there's another 3 million. So at this point, this data is very inconsistent. So as he is withdrawing and depositing, this data is very inconsistent. Okay, so this is what inconsistent read is. So at the end of everything, when now the CEO checks at the end, you'd find that the account will have 10 million at the end of it all. Okay, so it can only be correct if the CEO checks the balance before or after. But during these writings, the withdraw, the deposit, this data will be very inconsistent as time goes by. Are we good there? Are we good there? Kindly confirm with me. Okay, good. So the marked shows that if the CEO was to read data either before or after the data was modified, okay, the correct result of this data will be accessed. But now, if the read happens during the write, the data at this point is highly inconsistent, and therefore it is referred to as dirty or inconsistent read, which is write-read conflict. I put an explanation there. Unrepeatable read. Okay? Unrepeatable read happens when data is read before write. So before So this is what happens. Let me show you. So there must be a reader first. Okay, there must be a reader first, and I have to make mention a reader has to appear at least twice. So there's this reader here. There's this reader here. Remember, you are selecting, let's say, inventory from product where product ID is 1. Then again, we are selecting inventory of all prices from product where product ID is 1. So what happens is this. What happens is this. This is called a read-write conflict. So what happens is this. A reader will read a transaction, but a writer will come and write to that transaction. So you check everything is okay. Then someone come and make changes. So the next time you check, because changes were made, the next time we will check uh, 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 the data that you are going to get the next time you check will be different from the first time you checked that data, because at this point you read this, changes have not happened, have not occurred. Then changes have happened, so the next time you are reading, you are checking. Because of these changes, the first check and the second check, these will be different. This is what we are calling unrepeatable read. So unrepeatable read happens when data is read before write. So it is called a read-write conflict. Are we good here? Are we good here? Okay, good. You can write. So this is unrepeatable read. Why? Well, because data is first read. Later on, the table is updated. So the changes are made, and the column is set to a different value. The second time we read it, the value would not be the same since an update was initially made. We have what we are calling phantom read. These are common concurrence issues. So a phantom read is similar to unrepeatable read. Okay? Very, very similar. Unrepeatable read, remember, is you read first, changes are made, you read second, so your first read and your second read will not be the same because changes were made there. Then, phantom read, there is just a slight difference. So phantom read is similar to unrepeatable read. So a phantom read happens when data is read before addition or deletion is made. Please make the difference. Here, in a phantom read, it's either you add some data or you remove some data. Just two possibilities. Okay? So, you read the first time. Okay? After reading this, changes are made, but those changes are adding. Remember, insert into the table name values. You add values there. So you add nuts 10 8.99. You add this, and the next time you are going to remember, there's 10 here and there's 10 here. So the next time the next time you read, because there is an addition there, the first time you accessed will be different from the second time you accessed. Okay? But this phantom read is only limited to addition and deletion. So you either add values or delete values. That's phantom read. Okay, it is also called read-write conflict because reading happens first, then the writing happens second. Okay, I put an explanation for you there. Then lost update. Okay, this happens when a write disappear or when the change disappear. It is write conflict. So in this case, the lost update, both parties are making changes. So there's account 1, there's also account 2. So account 1 makes changes, account 2 makes changes. Account 1 has 100. So user wants to pull memory into account or money into account. Okay, so they want to put that money into account. User 2 also wants to put that money into account. Okay, so if initially we had 100 in that account, then we put another 100, the total will be 200. That means the first money will disappear. How is it going to disappear? The person that is going to check won't say, no, there was 100 here. It's possible 200 can be deposited at the same time. That means the first record will no longer be the first record. It will reflect the final record. So the first, the lost update happens when the write disappear. That's what we are saying there. Okay, so this is what happens. So we have 100 there. Okay, after having 100 there, we withdraw. Okay, so we have account 1 as 100, account 2 has 0. Then we withdraw 100 from account 1. So account and deposit it to account 2. Okay, so now account 2, for example, it has some value there. Since we withdrew that amount, assume this was 100. Okay, we have 100 there. I think this was bad. This was bad on me when making an example. So assume this is 100 there. So 100. So account 2 has 100. We withdraw that 100. Oh, this is 200. Though it's fine. It's fine. This is 200. I corrected. So get that. So account 1 has 200. Account 0 has 100. Okay. We withdraw 200. That is writing from account 1. And deposit that 200 into account 2. So account 2 would have 200. Then account 1 will be set to 0. So that record disappears. And we have a new record. That is write conflict. Quite important there. I put an explanation there for you guys. That is okay. Right. Can I get a thumbs up? Are we good up to this point? Are we good? Others just received the 2 thumbs ups. Okay, thank you for that. Not, this is not possible because that is just further explanation. Properties of database. This came in our exam. So there are 4 properties of database. We are calling that ACID. Okay. ACID stands for atomic, consistence, isolation, durability, or durable. Okay. Atomic. Anyway, we will explain in the notes. We wanted to talk about that. So ideally, DBMSS follows acidic properties. Okay. But sacrificing good behavior for performance is common. So acidic is refers to as good behavior, okay? But where performance is good morals, morals are overridden. Okay? You have morals, but you can't perform. You can perform, but you don't have morals. They would rather get a person that can perform compares to morals. So atomicity, which is atomic, these are properties of a database. Okay, remember what we are from looking at. Uh, uh, please pardon me for that. What we are from looking at are common concurrent issues. So atomic is operation encapsulation, but you can't remember that. You can just remember this. Okay, so what we are saying here, we can use this example again. Where is that? We can use this example again. Oh, we can use this example again. So, if this is a bathroom and this client goes to bath, they lock the door. They have to bath from start to finish. Then they move out. That's when this client can go there to bath. Okay? So the bathing of this client can't happen not until the bathing of this client, the bathing of that client finishes. Okay? So in the same way, atomicity or atomic, we are just saying, even if there are 10 transactions, transaction 1 must happen to completion. Okay? Atomicity states that if one transaction is executing or is in execution, it must run to completion, and any other transaction must wait. Okay? So, if one transaction is executing, any other transaction must wait. That is, an operation is atomic if everything works or nothing happens. If everything works or nothing happens. I hope you understand that. So, it means the system must only allow one transaction to happen at the same time, or the system must never allow any transaction at all. Everything works. That means when a transaction begins executing, it must execute to completion, or nothing happens. It means no two transactions must be allowed at the same time. Atomicity is the second most important acid. And feature user needs for programming. That's very important. They can ask you what is the second most important acid property? Atomicity. Are we good here? Don't worry, we'll stop very soon. Are we good here? Only one is good? Okay, good. Let us just finish up the acids. Consistency. Remember, it is acid. AC. C is consistence there. Okay? So, database is says to be consistent if and only if a transaction begins with a valid database state and ends with a valid database state. So, what we are saying, if you say 1 plus 1, the answer you expect is 2. So when we say select student from this, what you requested is what must be expected. That's consistency. It starts with a valid input so that you have valid output. Isolation, very, very important. Isolation is a principle that if there is more than one transaction in the process, all other transactions must be suspended. Okay? There are three processes. Okay? There are three processes. Process 1, process 2, process 3. If one process begins executing, all other processes must wait for this process to finish. Meaning, isolation behavior is as if an operation runs as if it was the only one running. And it is the most important feature of ACID. Functional transaction, very important. This came in our exam. Atomicity plus isolation. Second important feature plus the first important feature is equals to functional transaction. This is what makes a transaction to be functional. Atomicity, when a transaction starts executing, it must execute from start to finish. Isolation, if there are more than two transactions executing at the same time, all other transactions must be suspended until that transaction go through. Durability is about survival. That is durability. When they say this is durable, it means it lasts longer. Okay? So that is about crash recovery. So, if the system crash, how quick is it to recover? So, if an operation if an operation on the database fails in the middle of a process, you have to ensure that next time it starts executing from the point it stopped. It must never go back to first. So there must be a way of recovering it without slowing down database. So I think we can start from transactions on Thursday. We finish up this. We will talk about the transaction there. We will go into transaction modeling. We'll look at these very important. These are some of the concepts that we are going to look at. Maybe after this we'll look at a tutorial sheet forwarded in the group. We'll look at the tutorial sheet after looking at these concepts. Types of schedule, we'll look at these very important. I think these were exam heavy for us. These were exam heavy for us. We'll look at these. Very important. These very important. What these are. And when we look at these, we can now go back to the exam paper before us, because these are contained in there. So we can look at those. So we will start from transactions. We will be quite slow but sure, so that we get all the concepts that we need. Okay, so we will start from transactions there. Please, someone to take note of where we have to start next time, so that we don't yeah. Are we good? Are we good? If we have a question, please unmute ourselves. Otherwise, the video will be available tomorrow by 10. Video will be available tomorrow by 10. Yeah. Let me just hear your voices. Fanny, are we good? Pretend I can see your thumbs up. Okay. Any question, Gertrude? Thank you for that. Right. Have we gotten the concept? Okay. Kasako. Any question? Are we good? Have we got the concept? Are we happy? Any question? Okay, good. Perfius, are we happy?
Yes.
Okay. Thank you. We are free to sign out. Have a pleasant good evening, and see you on Thursday, God willing.